Launched in 2020, the engineering behind the Mars Rover, Perseverance, is purely ingenious. The rover is 10 feet long, 9 feet wide, and 7 feet tall. It is around the size of a car. The rover weighs around 2,260 pounds and is searching for signs of ancient microbial life. First, we will explore the rover's body and why it is so important. The body protects all the electronics, including the computer, which is another particularly important part. The body of the strong outer layer that controls the temperature of the electronics and instruments inside Perseverance. The top side of it is called the rover equipment deck. The equipment deck has the rover's cameras and mast on it. Now to learn more about the rover's computer, it is called the rover compute element. There are 2 copies of the same computer to be able to have one as a spare. Its special memory system can tolerate lots of radiation. It monitors the Mars rover's health by periodically checking the temperature inside the body and adjusts the temperature based on that. It also records the power generation and power storage data. The cameras are another key part of the rover for landing it, for certain tasks, and for collecting samples and observations. For documentation of the landing, descent imaging cameras and a microphone were used. The descent imaging cameras showed how the rover was doing while flying and landing in Mars. The enhanced engineering cameras were used to help humans drive the rover and to help with moving the arm, drill, and other tools. The hazard avoidance cameras detect hazards in front and behind the rover like large rocks, trenches, and sand dunes. There are 4 on the front of the rover and 2 on the back, and they all point towards the ground. They also can help see where to move the rover's arm. The 2 navigation cameras help engineers navigate the rover safely. It is located high on the rover's mast. The cache cam documents sample collection. It takes pictures of sampled materials so scientists can watch over them as they are being obtained. The 2 mast cams take colored photos and videos. It has good zoom and sees details of faraway targets. Supercam beams a laser at targets that are too far for the rover's arm to vaporize it and see the elemental composition. It can pinpoint an area less than 1 millimeter from 20 feet plus. It looks for organic compounds that relate to past life on Mars. When the laser hits the rock, plasma comes, and it records the spectrum of plasma, which shows the composition of material. PIXL uses X-ray fluorescence to discover chemical elements in target spots that can be as small as a grain of salt. The micro-context camera provides images to show the characteristics of the target. Sherlock's context images main tool is its spectrum and a laser. It has cameras that take extreme close-ups of studied areas. Helps scientists see textures that might reveal past details of the environment that it was in. Watson helps identify targets of interest for other parts of the rover. It provides views of the texture and structure in rocks and dust on Mars. It is located on the turret at the end of the arm. It can also take pictures of other parts of the rover to monitor how they are doing. The 2 microphones on the rover document the sounds of Mars rock soil and the rover itself. This gave scientists another sense of Mars. One of the microphones is on Supercam. It listens when Supercam is on or to the wind. It can hear other instruments on the rover. The other microphone was used to record the landing. It recorded sounds of descent. It hears friction in the atmosphere, winds, and sounds of dust blown by thrusters. Let's move on to Perseverance's legs and 6 wheels. Each wheel has its own motor. The 2 wheels in the front and the back also have their own steering motors. This lets the rover curve and swerve. The wheels are 20.7 inches in diameter. The rover can turn 360 degrees in place with all the motors. The suspension system or the legs connect the wheels to the rest of the rover and control how it interacts with the terrain. This lets the rover drive over rocks as tall as 15.75 inches. There are 3 components to the suspension system: differential, rocker, and bogie. The differential connects the wheels to the rest of the rover. The rocker connects the front wheel to the differential and bogie on both sides. The bogie connects the middle and rear wheels to the rover. This minimizes the amount the rover tilts. The rover's top speed is only 0.1 miles per hour. But, with that pace, it is energy efficient. The 7-foot-long robotic arm helps take samples from Mars. It extracts cores from rocks, takes microscopic pictures, and analyzes the elements of the rocks and soil. The drill, on the end of the arm, collects the samples and has 3 different attachments called bits. The coring and regolith bits collect samples in a sample collection tube. A brader bit scrapes off the top layers of rocks. This exposes fresh surfaces to study. The turret carries cameras, Sherlock and Watson. A ground contact sensor prevents damage to the arm if it touches the ground. The rock sample is about 0.5 inches in diameter and 2.4 inches long. Each sample is 10 to 15 grams. The rover has 43 sample tubes, and the goal is to collect at least 20. There are a few steps to sample handling. The first one is to collect them. Next, you have to leave it in a well-identified place. The rover belly holds the equipment for sampling and has a small arm in it. The small arm moves new sample tubes to the drill and transfers the filled ones to where they can be sealed and stored. Electrical power is generated by a radioisotope power system. This makes a dependable flow of energy. It is made by the heat of plutonium's radioactive decay. It is called the Multi-Mission Radioisotope Thermoelectric Generator, MMRTG. MMRTG converts the heat from plutonium into electricity. This keeps everything at the right temperature too. It is located at the back of Perseverance. NASA is working on a mission to collect all the samples the rover took on Mars. Perseverance is a remarkably interesting machine with amazing engineering behind it. I hoped you enjoyed the video and learned something new.